Playing with prime and composite numbers, let's play more specifically with the greatest common factor. Now, the greatest common factor is abbreviated GCF, and there are two ways to do this. We can find it with the list method or the prime factors method. Now, again, very similar to the least common multiple, it kind of depends on the numbers that you have, which one of these is easier. So check them both out, make your own decision. We use the GCF to simplify fractions and also when you get to factoring. Such fun. All right, let's start with the list method. If we're going to use the list method, we have to list all of the factors that make up a number for both numbers, and then we choose the largest factor that works with both of them. So we're going to start with 15 and 20. So we have to list out all of the factors. So when I'm talking about 15, okay, well, what multiplies to get 15? 1 and 15 and 3 and 5. Okay, so there's my list. That one was pretty straightforward. Now let's go to 20. Okay, well, what multiplies to get 20? Well, 1 and 20. 2 times 10. 3 doesn't go in. And 4 times 5. The way I wrote that, when 1 times 20, I know those are kind of like the barrier numbers. I like my numbers to be in order least to greatest. That way, when I say, okay, I need a common factor. Well, common means shared among both groups and greatest. So I look at the end, right? 20 is not in both. No. Oop, 5. 5 is the biggest number in both. So my greatest common factor is 5. So when you look at that, if you want to look at it a little more nicely drawn here, you list out the factors. The common factors for these numbers is 1 and 5, and the greatest, the biggest one of those is 5. Okay, you try one using the list method. List out the factors of 18 and 24, and then look at the biggest number that they share. So the factors of 18, 1 and 18, well, it's even, so 2 times 9. 3 goes in, 3 times 6, and that's it. Then I go to 24. Well, 1 times 24, it's even, so 2 times 12. 3 goes in, 3 times 8. 4 goes in, 4 times 6. Okay, so as we work our way through, 18 doesn't go in the other one. Nope, not 9. Yep, 6. There it is. So our GCF is 6. Again, if we want to look at that a little more nicely here, you can easily see the common factors when you list them out. 1, 2, 3, and 6. What's the biggest number there? 6. Okay, so that's great if you're dealing with just two numbers that are pretty easy to work with, but sometimes that's not the easiest. So let's look at the prime factors method. With this, we're going to find the prime factorization of each number. I like to use a factor tree for that. And we'll write each number as a product of primes. Now, because we're finding the common factor, we're going to look at what factors are common between our product of primes, and we're going to use the lowest exponent that appears. Multiply these together, you have your greatest common factor. Let's do one of these and show how beautiful it is. So the greatest common factor of 48 and 80. So let's start with the prime factorization of 48. Well, I see 48 is 4 times 12. 4 is 2 times 2. Those are prime. 12 is 3 times 4. 3 is prime. Break down 4, 2 times 2. So there are 4 2s, so this is 2 to the 4th power times 3. There's my prime factorization of 48. Then we go to 80. Well, 80 breaks down 4 and 20. 4 is 2 times 2. 20 is, 2 times 10. And then 10 is 2 times 5. I lost my other 2 here. All right, so we have 2 to the 4th times 5. When I look at my two numbers now, I'm not sure how I got this here. Okay, I have 2 to the 4th times 3 and 2 to the 4th times 5. What do these two items share? They share 2 to the 4th power, and therefore 2 to the 4th is 16, so that is going to be my greatest common factor. So when we go to looking at this a little nicely, 2 to the 4th times 3 2 to the 4th times 5. Again, you're looking at common. The key word for the greatest common factor is common. When you compare them, you can easily see that 2 to the 4th is in both of them, so that 3 is only in one, 5 is only in one, so we just want the common piece of 2 to the 4th. All right, you try one of these. 36 and 54, find the greatest common factor using the prime factors method. So if we do 36 and I break it down, well, 36 is 3 times 12. 3 is prime. 12 is 3 times 4. 3 is prime. 4 is 2 times 2, both prime. So I have 2 squared times 3 squared. And there's my prime factorization. Over to 54. 54 I can break down to be 6 times 9. 6 is 2 times 3, both prime. 9 is 3 times 3, both prime. So I have 2 times 3 to the 3rd power. So now we have to do a little bit of thinking and say, okay, what is common between them? Well, if we look at the 2's, they both have a 2. I can pull a 2 out of each one. If I pull a 2 out of 54, it's gone. If I pull a 2 out of 36, I'm down to just 2 to the 1st. But there's no longer common because we've ran all out of 2's. Then we look at 3's. Okay, so let me change colors for fun here. We go to 3. Well, in 36, we have 3 squared. That's 3 times 3. In 54, we have 3 cubed, which is 3 times 3 times 3. So how many are common? Well, 1, 2, 2. I can pull 2 2's out of each one. So that's why during our rules, we talked about the lowest exponent, because if I have 3 squared, I can only take 2 of those 3's out of each one. I will have an extra 3 over here in the 54, but I'm all out of 3's in the 36. So I just end up 2 times 3 squared, which is 18. So I don't know if that made a whole lot of sense. Hopefully it did. But then also check, does 18 divide evenly into each of these numbers? Yeah, sure does. And that's how you can tell if you have a greatest common factor. So again, with these two numbers, having it written out a little more nicely here, 2 squared times 3 squared, 2 times 3 cubed. So when I look at my 2's, the smallest exponent is 2 to the 1st. Compare your 3's, the smallest exponent is 2 squared. And that's how we end up with 2 times 3 squared, which is in fact 18.